Welcome to another version of SoilWorks Soil Solutions. We're fortunate enough to have Dr. Tom Dykstra, an infamous scientist with a wealth of knowledge and traveling wisdom. And today, do you have any objections if we talk about soil pH and the life of soil in these pHs?
Ooh, objection, Your Honor. I'm just
Moving
kidding.
right along. We do a lot of traveling, both of us, in
Yep.
different areas. And I'm hearing a lot of growers are saying, well, our soil is an 8.2 pH or it's an 8.3 pH. And everybody says that's just the way it is. Can't change it. What do you think about that? Can you change the pH?
The pH can be changed, but there are conditions in the soil which will account for a higher or a lesser value. So some of the things that you can change and that we have talked about many times before is bringing life into the equation, because life has the tendency to buffer pH. And so any fluctuation, whether it be too high or too low, can be buffered if you have the necessary microbes in the soil. And oftentimes we don't. And so this is part of the problem as to why we are dealing with that.
Okay, so did the lack of microbes in the soil cause the irregular or high pH?
In some cases, yes. In other cases, no. Because there are some soils that are just going to be a little bit different than other soils, no doubt about it. And therefore, because you have these soils where we're told the defeatist attitude is, this is just the way it is, at that point, the plants need to make a decision. Can they survive there? And if they can survive there, what do they have to do in order to survive in, as we said, an 8.3 pH soil?
To generalize, and I know you hate this.
Can't do it.
Being a doctor, where is there a pH that most plants enjoy the most?
Most of the plants prefer it to be in the 6 range.
Mid-6s?
Mid-6s, yeah. The 6.4 has been talked about a lot. That's certainly a very good pH level to be at. Is it a big deal if it's a 6.3 or 6.5? No, it's not a big deal. But the farther you get away, the more problematic it can become, with some exceptions, because we have citrus in Florida, and blueberries too are pretty good at going down into 5s on the pH scale, and they can do that. So that's not as much of an issue with them. But even they have a chance to regulate the rhizosphere, because the movement of nutrients across the root membrane are dependent upon the health of the plant and its ability in order to move things back and forth. And you cannot move things back and forth, generally speaking, in an 8.3 soil, because we were told, and me and my colleagues, we know this, we cannot break down metals in 8.3. So therefore, the question is raised, if we can't break down metals, we can't break down iron, we can't break down manganese, we can't break down copper. How is the plant even living? How is the plant even surviving? I don't even get how this happens. But we have to understand that this is not just about the soil. We have the plants, which are also putting their own 2 cents in about what they can survive in and how well they can survive in. And the ones that can survive in 8.3 soil do survive in 8.3 pH soil.
How? In a short answer.
In a short answer, what they do is they will regulate right around the rhizosphere. They do it with electrical conductivity, and they also do it with the pH. So if this is a root that is extending down, you will have a very, very tiny amount, a very small area right around the root that will be in that 6 range. That's all the plant can handle. It's completely surrounded by 8.2 pH soil, and it's not going to have the health and the oomph in order to spread that influence out too far, because it takes too much energy. So when a plant is able to regulate the rhizosphere, and of course we're talking about soil, so therefore I'm talking about the roots in the soil. I'm not talking about the stem or the leaves on top of it. The roots have the ability, in order to regulate at the smallest level just enough in order to survive. This is why some plants can survive in 4 or 5 pH soil. This is why other plants can survive in 8.3. If they have the ability to do that, they will, but they're all dealing with the same limitation, and that is they need to be right around 6 in order for nutrients to pass and therefore break down. The microbes need to do that too, and so they create just this very, very tiny region, and it is absolutely detectable. We can detect it, for example, with the electrical conductivity meter. So if you have an electrical conductivity meter that is big, and there are some big ones out there. Notice I'm holding the weapon now. These big ones, this is a penetrometer right now, but imagine it's electrical conductivity. When you place it into the soil, we can actually get nothing, nothing, nothing. You can spend 100 times doing that, and then you stick it in, and then you hit a root, and it will shoot up to 0.6. Before that, it was at 0.1 or below in our sandy soil, 0.1 or below. And then suddenly we shoot up to 0.6, and that's when we know we hit a root, where the electrical conductivity can be regulated just around a root, because that's all it can afford. The healthier the plant, the farther the distance out from that root, it will be able to maintain enough conductivity and the pH at the proper value.
You said an 8.5 pH or something similar to that, the plant can survive in that.
By regulating its own rhizosphere, yes.
Is that the goal, is just get these plants to survive in it?
Um,
or to thrive?
Well, thriving, well, that's...
Okay, before you go on,
Yeah.
what if you were to create a soil that was just, say, a 6.3, 6.4, 6.5, where the plant loved the environment? You were 100 to 150 psi. You had a nice conductivity of a 0.3 or 0.4.
Yeah.
The plant wouldn't have to exert or expel
Yes.
that energy to try to correct the environment, so that could be added to yield.
But the perfect soil doesn't usually exist.
Okay. On that, a lot of people talk about pH.
They do.
Some people say, well, pH stands for possible hydrogen or probable hydrogen. Some people even say it stands for potential hydrogen. And this is where a lot of people are going, what are you talking about? So if you're looking at potential hydrogen, anything over a 7 pH has a greater potential of hydrogen. And people say, whoa, what's this potential? And I'll do the, if pH stood for potential hair, I would have a fairly good potential. What I mean by that, taking it back.
No comment.
Thank you. What we looked at is a 7 pH or higher has a great potential, but 0 actual hydrogen. Take a look at your soil test. The base saturation, where they want 68% base saturation of calcium, 12 to 15% base saturation of magnesium, 3 to 4 to 5% base saturation of potassium, you'll come to hydrogen. If it's 0, how is the plant going to make sugar if it doesn't have the raw ingredient hydrogen?
It cannot.
Boom. So now you got fungal diseases, you got insects, you got weeds, just because of a deficiency of probably one of the lightest, squirreliest, most volatile elements on the periodic table, hydrogen. How do we stabilize hydrogen in the environment of soil, and how did some of these pHs get so far out of whack? And I'm going to throw one more thing in there. We have calls from different parts of the country and different parts of the world, and they say, well, our pH is an 8.2, 8.3, 8.5, and our companies are just saying that's just the way it is. That part of the country, that's just what it is. Just deal with it. Can you change, improve? And what would be the shortest, quickest, easiest addition to maybe lowering a pH of the soil?
This is called a leading question, where he asks the question, but he knows the answer already. Let us stop and see how this turns out. What I'm going to do is I'm now going to turn the tables on him. Watch this. I'm not sure. I have really no idea. Do you have any idea how this works? Oh, no, 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 no. Oh, no, 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 no.
Go ahead.
pH can be changed. It is hard. And the reason why I say it is hard because for those who have changed pH before successfully, so if you're sitting at 7 or 8 pH, you can throw down something and gypsum, something like that, sulfuric acid. Get the pH down. What you will notice is that it works. So you can lower the pH and you can raise the pH. Mankind has the capabilities of doing this. But what happens invariably after you do that? Goes right back to where it was before.
So it didn't fix it.
It didn't fix it. It's a temporary fix. This temporary fix is expensive. And the reason why it is done is because of all the parameters of testing. For some people, pH is at the top. pH is the first thing that you need to do. Whatever's second is a distant second. So we need to be able to change the pH first, and we need to be able to do it as fast as possible, and then we can have a conversation about whatever is second in their particular minds. This is a problem.
I'm glad you brought that up because a lot of growers in California have spread mountains of sulfur, Tiger 90, gypsum, and they will see the pH come down for a little bit and then, like you said, go back up. So it didn't fix anything. And every year they put a little bit more gypsum down or a little bit more Tiger 90. And my old professor said, well, they have introduced themselves and invited themselves to the moron theory. Well, a little bit works, so we better put a little more on, and a little more on, and a little more on, and pretty soon you become what you're doing. It's not solving the problem. Here's an angle. What we've seen is carbon. In fact, there's a science that deals with just carbon. Some scientists call this organic chemistry. Why don't any of the agronomists or the professors talk about organic chemistry, the study of carbon, and carbon can make more relationships than all the other elements combined.
Yes, yes.
And carbon, when it's introduced to the soil, will stabilize 7, 8, 9, sometimes 10 times its weight in hydrogen. So as it stabilizes, it adds actual hydrogen, reducing the potential hydrogen and creating the environment that you said the trees love to have. Can it be as simple as putting different forms of carbon, sugar, molasses, grass hay, alfalfa hay, good compost, leonardite, humulite, a little bit of fulvic acid, humic acid, different carbon sources to feed the microbes? Because I'm guessing there's some microbes that may produce lactic acid?
Yes, your guess would be correct.
Okay, so let's throw in, since we went lactic acid, let's come a different angle, bicarbs, bicarbonates. I'm not a chemist, help me out here. A bicarb...
I'm not a chemist either.
A bicarbonate is a high pH between 8 and 9 and has a chemical formula of HCO3.
CO3.
That's the problem. If we can identify it and look at it, how do we take that problem and turn it into a solution? When you add microbes and food and oxygen to the soil, microbes, the bacteria, the aerobic microbes, start to party. They're eating, they're breathing, they're huffing, they're puffing, they're exhaling CO2. And there's a lot of CO2. And if a little water comes in, H2O and CO2 form, and you know it, carbonic acid. pH of between what, 4, 5?
Yeah, thereabouts. Yeah.
So if you feed the microbes, if you allow them to breathe, they will change, correct, improve, balance the pH of the soil so everything becomes more efficient. And on that, does phosphorus availability change when you're above 7 pH or below 6 pH? Is phosphorus more or less available?
Let's see, does this have anything to do with phosphoric acid?
Possibly.
Possibly.
Well, and phosphorus is a big one because phosphorus has to be in the P2O5 form to get to the plant. Has to have a lot of oxygen. And a lot of people are saying, oh, we've got a phosphorus deficiency. We've got a phosphorus deficiency. Well, you may have a phosphorus deficiency in the plant, which you have seen because you have done extensive sap work. Is that accurate? You've probably done more work with sap than any other human on the planet on a scientific level.
Not more than anybody on the planet. There are people who have definitely looked at it.
But you're a contender?
I'm a contender.
Okay.
I can hold my own
on
a plant sap analysis.
So what we're looking at, when you're looking at a soil test, if your pH is over 7, the first thing I would say is look at your carbon to nitrogen ratio, and that's going to be low. Because if you have a pH of 8.5, are the microbes at a pH of 8.5 the same microbes are going to be in the soil at a 6.5?
No, they will be different.
And I'm throwing it out there, once you create a better environment, you'll get a better or more of a constructing microbe?
Yes, yes. The microbes that will be around in the 6 range are going to be more conducive to plants. These are the type of microbes that the plants are comfortable with. Yes. Yeah. Yep.
So, by improving, balancing, changing the pH, looking to see where it's at. If it's too high, you need carbon. If you're over 7, you need carbon.
Yes, even 7. Even 7.
Yes.
That's correct. Yep.
And what's your choice of carbon to get things rolling?
My choice of carbon? My choice of carbon has always been sugar because it's the fastest.
Table sugar?
In order to be incorporated. Table sugar work if that's all you've got.
Cane sugar?
You can do better. Cane sugar is better than table sugar. Keep going.
But if you get a bag of cane sugar and put it on the table...
All right, dirty sugar. Dirty sugar. All right.
Well, and the thing of it is, whatever you're looking at, the addition of carbon, oxygen, and hydrogen, which makes up the majority of the dry matter weight of a plant, if you're not getting as much yield as you need, it's probably because of one of those 3 things is deficient.
Well, that is correct. Sugar is the quickest thing in order to be incorporated in because it's microbial food. It will be eaten immediately. I mean, within a matter of seconds after it is applied, it will be started to be consumed, and at that point, the microbes will party. I believe is the term that he used. They're going to be breeding as well. How am I doing?
Quit.
Not done. I'm just going to stop right now.
I think they got it. Well, and what we've seen is, that's one of the things we make the calcium for, is to open up that soil to let those microbes breathe.
Yeah.
To put the sugar in there to feed them, because, and there's a little, I'm going to kind of go on a tangent for just a little bit.
Don't lose me.
I'll go slow and enunciate. But microbes are doing the eating, breeding, partying. They're giving off carbon dioxide.
Yes.
So if you have a lot of carbon in the soil and that ground dries up after an irrigation and seals over, hard as this table, there will be a fight for the remaining oxygen in that soil after it seals off. So, since you're not a chemist, whiner, We want CO2 because that's what the plant wants. That's what the microbes giving off. That's part of the carbon cycle. If we take one oxygen molecule away from carbon dioxide, what does that become?
We get carbon monoxide, which is a lot of fun.
Oh,
at a party.
Yeah.
Yes.
and oddly enough, we have tested soils that have gotten tight, sealed off, and these guys are saying, just don't know why your trees don't look good.
And the microbes aren't doing well because they're being killed by the carbon monoxide.
They're being gassed.
Yeah, they're being...
So the carbon monoxide isn't the greatest thing in the world.
Not the greatest thing in the world.
And so we can go one step further. That last molecule of oxygen gets ripped away from the carbon, and that's what happens. A lot of guys will throw a lot of carbon in the soil, but they forget about the calcium to relax things. And so carbon...
Very reactive.
Carbon in an oxygen-less environment, and the trees aren't doing good, and here comes the local co-op and say, well, you need a shot of nitrogen. So you throw nitrogen down in a tight, airless environment that you just put carbon in, what do you have the ability to form?
Oh, it's even better than carbon monoxide. Are you ready for this?
There's more.
There is. Cyanide. Yeah. Cyanide. That's also really good at a party too. Yeah.
So,
not the parties that I've gone to, but, you know, other types of parties.
Do not invite the doctor to your home. I think his medication's starting to wear off.
I think it is.
Well, and this whole thing is, so people are saying, well, I need to throw more microbes out. Or I need to look at this or look at that. It's like, how about, like we talked before, the do-it-yourself field analysis. Check the air, check the heartbeat, and check the energy or the fuel level.
The fuel level in the plant, because the plant is feeding the soil. Yep, that's its job.
And anything else you want to add to the soil pH?
Do I want to add anything? You know how much trouble I'm in already? Do you know the comments that people are going to be making about the party? I cannot
really
add to this.
hoping that he wouldn't add anything.
No, I have nothing more to add. I so want to end this video as fast as possible.
If you're looking for a do-it-yourself field analysis, crop analysis, soil analysis, or if you're looking to improve, give us a call or email us at SoilWorks, or if you'd like to have a professional doctor consultant that I believe in a couple hours, if given the information, you can save growers an obnoxious amount of money by pointing them in the right direction on what the best choice is first to fix the easiest, quickest, cheapest improvement.
Sure, I can do that. I can do that. Yep.
So Dr. Dykstra at Dykstra Labs, Glen with SoilWorks, we hope this has been informative and we appreciate you watching. Thank you.
Thank you.